All right, welcome to example 3 here in section 4.4. So you've already seen how to factor some larger degree polynomials. You saw that sometimes when you have a sum or difference of cubes, you've got nice little patterns and formulas just to plug your values into. But not all of your polynomials are going to be set up that way. And sometimes there aren't common factors that you can take out of every term. So when that's the case, such as in this one, you'll notice there aren't common factors that you can take out of these. We have to think back to when you first learned factoring in Algebra 1, for example, and what you had to do is, since you couldn't take a term out of all of your expression, you can't take a factor out of every term, you want to go ahead and group your polynomial into expressions to smaller quadratics that do have common terms. So for example, this one, we've got a 4-term third degree polynomial, and some of our terms have common factors. Like for example, here we've got z squared in both of these terms, and here we've got -4 in both of them. So we group them together so that we can just factor out that term, that factor, out of our binomial instead of taking it out of all 4. Basically what we're doing is recognizing that as one big polynomial we can't factor anything out, but if we made these into smaller groups, then we would have a common factor to take out of just those small binomials. So that's what we're going to be doing in this example. So I already showed you how we can group these by just putting parentheses around these first two and last two terms. Now you'll see we already mentioned z to the third power and 5z squared both share z squared, and minus 4z minus 20 each share -4. So if we go ahead and group those and take out those common terms, our expression is going to look like this. We're left with z plus 5 when we take out z squared, and we're left with z plus 5 when we take out -4. So sometimes these aren't going to be lined up properly. You may have to shuffle around the order, but when you find terms that do have common factors, just put them next to each other and factor those out. Now, again, you did this in Algebra 1 when you had to factor some polynomials. What we see now is that z plus 5 is a common term. So what we can do is set this up as two binomials. If we take a z plus 5 out of both of these, we're left with z squared minus 4. And what we do when we get that is we've got z squared minus 4 times z plus 5. Again, look how this worked out. We've got two terms here. The first is z squared times z plus 5, and the second is 4 times z plus 5. When we take this term in blue here and factor it out, we're left with z squared minus 4. Okay, so that's how we get these two binomials. Now another thing that this example is showing you guys is that even after you follow through all the steps in factoring your original problem, you may not always be done. Once you have your factored expression, you may run into a case where there's another polynomial in one of your subsets that can also be factored down. So I'm hoping that this jumps out at you right now. But if you look at z squared minus 4, you should recognize that as the difference of two squares. We've got z squared minus 2 squared. So z squared minus 2 squared. And that should be pretty simple for you guys to factor into just z plus 2, z minus 2. And again, don't lose the z plus 5. You've already factored down into that. You can't just drop it. Your final product ends up being 3 sets of parentheses. You've got your difference of squares, which you just factored out, and z plus 5, which we factored out originally. So your final expression is these three sets of parentheses, three binomials, all multiplied by each other. Again, order doesn't matter. Wouldn't matter if z plus 5 is in front or if these were flipped around. But this cubic polynomial factors down into three sets of binomials here.